Fifth grade, what is up? This is the fifth grade science fair information session number 4, and it's going to be about designing our procedures for our science fair experiment. This will be due Tuesday, March 24th. Now, I already sent out an email, but I will let you know again that if you are doing a project for the science fair that's going to require you to go out and buy materials, or you have to go physically somewhere and do something, then you do not have to start your project yet if you do not feel comfortable going out somewhere or getting materials. However, you still need to design your procedure as if you were going to do that. So ideally, when we get back from school in a couple weeks, we can get it started on the experiment. However, you still need to do this design procedure, and you need to warn everyone as you start that you are going to stand back, you're going to try some science. So once again, this design procedure, which goes hand in hand with that worksheet that I gave you guys, is due Tuesday, March 24th. So we need to make a plan first. What you need to do is you need to make a plan to test your hypothesis. So you have that hypothesis. You need to decide what materials you need and make a list, write them all down, and then you need to document the steps that you will follow in that test. So an example of a materials list. When you list your materials, you are being specific. You need to use the metric system as we talk about. So the materials list section is a detailed list of everything used in that experiment. Include what, how much, and what kind of things. So on the left is a non-example. So don't just put water, flower pots, seeds, dirt. Instead, put 5 liters of rainwater, 4 centimeter clay pots, 12 bush bean seeds, 10 liters of potting soil. You see how specific you are. You give measurements, you give what they are. Make sure you list your example. You need to make sure that someone can recreate it. So why write those procedures as our baby is asking? All right, so you know what you're doing, okay? You need to know what you're doing. If you don't write it down, you won't have a clue. If anyone wants to recreate the project, they will have the instructions to do so. And if something doesn't work, you can go back and see what happened. So there's a lot of different reasons to write down your procedure, but those are 3 of the main ones. Now, if we remember, just to use our example, let's go back to that apple experiment. Remember, for a proper experiment, you must have independent variables, dependent variables, and a control group. I know, ugh, science words and super scary, sad, annoying things. However, they are not as difficult as they appear. For a science experiment, we talked about how it needs to be quantifiable. You need to have data. You need to be able to recreate it. You need to be able to explain it and analyze it. So if you don't have independent, dependent, and control group variables, you're not going to know what you're doing. So let's just say you take that experiment again. You want to test how lemon juice affects apple freshness. If I put lemon juice on the apple slice, then it will not turn brown because the juice keeps the apple slice from reacting with the air. That's our simple hypothesis that we've already worked on before, that if then because statement. So here are your following variables from that experiment. I'll give you a chance to interact. So control group, you can yell it at the screen if you want. A standard against which change is measured. What is that? I'll give you a second. In our experiment, the control group is, these are your apples without lemon juice. Good, if you said that, well done. So your control group, that's the standard against which change is measured. Your normal, typical situation. You are not going to put lemon juice on the apple. Okay, so you're going to cut up these apples. You're going to have 2 apples, and you're going to have one that you don't put lemon juice on. You're going to have one that you do put lemon juice on. So your control group is the one you don't. You leave it alone. You want to see what happens if you don't experiment on it. So your experimental group is what you experiment on. That would be the good. The apples with lemon juice. Well done. I'm sure you all said that. So apples with lemon juice. So again, your control group would be the ones without. Your experimental group is the one you were experimenting on. You were doing something to it. Your independent variable is the variable that you control. So you are controlling something. You are directly changing this. And in our experiment, that would be, well done. It would be the amount of lemon juice you put on the apple. So the variable that you control, you are directly changing how much lemon juice you put on the apple. You cannot change how it reacts to it. You cannot change the freshness content of it. You can't change how big the apple is. You can change the size of pieces, but that's not really going to affect your experiment. Okay, what you're changing is the amount of lemon juice you put on the apple. That will directly change what happens. Which finally leaves us with the dependent variable. These are changes based upon the independent variable. So it changes based on the amount of lemon juice. Well, what changes based on the amount of lemon juice we add, that would be wrong. I'm sorry, you were wrong by saying that. It was the apple brownness. It would be the apple freshness or the brownness of that apple. Okay, so your apple brownness is going to be directly affected by how much lemon juice you put on. Okay, so you need to be able to figure out what those are in your experiment. So I'm not going to read this whole thing for you. You can pause the video here. This was just another little example, how to test the absorbency of nappies, which I assume are some type of drink, something. Huggies, Treasures, Pams, and Reusable. They are, if you read this, this is just a way to write out your experimental procedure, and you can see how accurate they are about, I could go and recreate this. You could all go and do this without even, I don't even know what nappies are, but I'm sure I could figure it out based on this. So pause this, just take note of this, and try and model yours off of this. So remember, please be specific and don't be lazy. This would be an example of a bad material list. Measuring stuff, fruit, a dish or something like that. Like a shirt, maybe, and fire. That will give me, that unfortunately can't, stare at you like this, like I normally would in the classroom, but that would be an example of bad material list. You need to make sure you're specific. Please be specific once again with your procedures. Write them out step by 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 step, and you get the point. Not this. I'm going to take some fruit, see if bacteria grows on it. I'll let you know how it goes. That will make me certainly flip a table. So make sure your procedures are accurate and they are specific. Once again, it is due on Tuesday, March 24th, and if you follow that, you will be successful. Now, just a little tips for how we are going to approach it for the way we're doing it online. Please feel free to email me a lot. Email me, submit these things. You can post them on Schoology. You can email them to me as much as you can. Take screenshots, and I will give you corrections just like we normally would. If you want to email it and make sure that it looks good, just keep that communication open as many times as you want. I'm around. Again, even if you cannot start your experiment yet, you need to write out the procedures. Right, so you need to still get those procedures written down and listed about, so as soon as we can get us back on track with this experiment, we can get started. So this is pretty much going to be the only thing you have to do Wednesday, Thursday, Friday until Tuesday. There might be one other thing I throw in there on Schoology, but I want you to focus primarily on this, and then we'll pick back up with the muscular system on Tuesday. All right, be safe out there, wash your hands, and we'll talk to you later.